Hello, I'm going to go over the quiz topics fairly quickly because I have a lot to do. I've been postponing my homework and it's all due tomorrow, so I got to get started on that. But I've made a video. It's about 12 minutes on an applied optimization problem, kind of explaining it. So I won't talk too much about that. But the first one is says you need to interpret the graph of a derivative of a function and what it means about the behavior of the original function and the second derivative. So it might sound a little bit complicated, but if you narrow it down, it's not too bad, okay? So basically, interpret a graph of a derivative. So you're looking at the graph of a derivative. For some simplicity, let me draw a better graph for you guys. You guys are worth more to me than that curvy graph, okay? So here's my little graph. Bam, 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 bam. And we're going to make it a cubic? Yeah, a cubic function. An ugly cubic function, but a cubic function, okay? So let's just assume that this right here is f prime of x, okay? This function is f prime of x. So we're looking at the graph of a derivative of a function. Let me switch to blue. We're looking at the graph of a derivative of a function, and we need to see what it means about the behavior of the original function, and then what it means about what it tells you about the second derivative. So first, let's look at the original function. So what is it going to tell you about the original function? It's going to tell you the slope of the original function. So each of these values right here is the value of the slope of the original function. So in some places it's positive, like right here it's positive, and then it goes positive forever right there. And in some places it's negative. So right here it's negative, and then right there and there is negative. So let's just call this -1, and then let's just call this 2, and I'll call that -3. That kind of scales, sure. This is -3, and these are x values. So you can see from -infinity to -3, it's a negative slope. And then from -3 to -1, positive values. And then from -1 to 2, negative values again. And then +2 to infinity, positive values. So since this is giving you the function, this is giving you the values of the slope, that means that you're not going to be able to draw a perfect graph of the function, but you can get a good idea of it. So, ooh, that line is not straight. Okay. Much better. Okay. So I'm going to do that real quick. Make sure I get the arrows. And then I'm going to really quickly bring those points back. There's 2. There's -1. And then there's -3. Okay? And their x values, of course. So we know that from -infinity, so -infinity all the way up to -3, the slope is negative. So we know that the original function is going to be going downwards. It's going to be going downwards, right? And then at x equals -3, we see that the value of the derivative is 0. So that means it's going to change. It's going to go up. It's going to flatten out, because when the derivative is 0, when derivative equals 0, then the slope is a horizontal line. So slope right here, I'm drawing f of x. Sorry, I'm getting all over the place. I'm drawing f of x. So right here, where the derivative is 0, the original function, a -3, has a slope of 0. And then it's positive until -1. So it's positive, 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 positive. And then it starts getting closer to 0. And then at -1, it's 0 again, right? And then from there, you see that it's negative. So now the slope is going to start going down until it reaches -2. Okay? and then once it reaches -2, it's going to, oh gosh, it's going to level off. Again, I can't draw this part of the slope. Ooh, okay. And now the derivative, you can look back, is at 0 and at +2. The slope is 0. And now for the rest of the function, it is going up again. Whoosh, because the slope is positive. So the derivative doesn't give you the placement of it. Like this graph that I drew in green could be all the way up at like this value being y equals 80. You don't know because it only tells you the slope at each point. It doesn't tell you the location. You can also, just to double check yourself, you can see that this derivative was a cubic function, right? So boils down to x to the third. So if you do your reverse chain rule, you know that to get to this being a derivative, that exponent had to be a 4 before. Because when you take the derivative of x to the fourth, it becomes x to the third. So you can tell, since this is a cubic, that the original function is going to have to be, I want to say it's called a quartic. This is what it looks like. It's like a parabola with the little, it's like two little, like a W almost, like that. But yeah, that's how you can check yourself. And then, so that's what you can tell from the function, about the function from the derivative. So that's what it means about the behavior of the original function. Gives you when the function is increasing, going up, or decreasing. And now, what it means about the second derivative. So the second derivative gives you the slope of the slope. So basically what you can tell about the second derivative is that from, let me write that number 2, and let's draw that 1 right there. So the slope of the derivative function now. So we know at x equals -2 and x equals 1, the slope is going to be 0. Oh, whoa. Slope is going to be 0. Because I'm just pretend that's where it levels off, you know. Slope is 0. So I'm going to rearrange things for you guys real quick. Move that down right there. Whoa, I took this with me. Oh gosh, very unprofessional video cinematography going on here. Okay, you know, we already went over that, so I don't think it really matters. Oof, okay, there. So and I wanted to move this to the side. Move that to the side. So if we know that at x equals -2 and x equals +1, that the slope is 0, then we know that the second derivative at -2 and +1 is going to have a y value of 0. Okay? And then we can see from everything before -2, so all of this right here, that's going upwards. You're going from, looking at it from left to right. It's going upwards. So then you know that your slopes are going to be positive. Okay? And then once it gets to that -2, levels off, and then the graph starts going down. So then you know the slope is going to be negative. And then once it gets to that +1 again, it starts going up again. So it's going to be positive. So there, you can draw what the derivative is going to look like. And then you can also check yourself in a way similar to what we did before. But since you know this is a cubic function, if you're taking the derivative, the power rule is going to bring it down a power to a parabola. And look at that. The second derivative, f prime prime of x, is a parabola. So this kind of should be what you should be thinking about for the quiz. This should be similar, being able to look at the graph of the derivative, this derivative right here, and putting something like this together. Now, I'm not going to guarantee that this is what the quiz is going to look like, because there's a lot you can do with that kind of thing, but it's probably going to be a similar concept to this, to be able to go from the derivative to the second derivative, and then to be able to go from the derivative to the original function. Again, with the optimization video, the optimization problem, I made a video that goes kind of in depth about it, and I walk through a problem. So I'll be providing you guys with that link as soon as it uploads. But that's all I have for right now. If you have any questions, feel free to ask me. I hope this helped. If not, I'm sorry. Please don't sue me. This is community service for me, okay? So I'm sorry. But good luck, team.